This is a graphical interface for a touch screen with SPI. It is a 3.5 inches one and the resolution is 480 by 320. It will be driven with a STM32, although can be adapted to any other microcontroller. It can be opened from two sources. In fact, it consists of two projects. The final aim is to create a project in C to download to the real hardware. This project will be opened with a STM32IDE. I used STMCubeIDE 1.7.0. For a very simple graphical interface, you probably will not need anything else. However, if you plan to design your own and complete graphical interface, I must say that debugging the code is slow and requires the connection of the hardware. This is because you can do these steps in a more comfortable environment. So, in the second half of this video, you will learn how to open a Visual Studio project or any similar that manages Win32 projects in C++ to develop 95% of the graphical interface and its functionalities. This is faster and does not require connecting any hardware. Once it is tested in your PC or laptop, you can complete your project with your microcontroller ID. These are the steps that we have to follow in order to download, compile and test a graphical interface that can be used as a template for your own designs. We will see next. And let's see how to do it. First, we get into this web page, and inside this folder we download this compressed file here, for example, and after downloaded we extract it, okay, we can suppress this, and this is the set of folders that we need. These are the folders that correspond to my own design, to my scoreboard design, but you will have to modify in order to fit to your convenience. And it's time to open our IDE. It takes a while to open, and we have to start a new project. We have to select our board, our board is a Nucleo 64, specifically the 103. We type any name. Yes. And after a while we have our project and we don't have to touch anything. Only I usually prefer copy the necessary files and use references for the not necessary ones. And here we have our project and we have to do some steps. Let me organize this. First, we have to copy the downloaded files in our project. In fact, I don't need to copy, I only need to link the files to my project. And also, I have to tell the compiler where are my header files, so I must select where are the folders where the header files are. I have to include two folders. The first one contains all of the generic header files related to driving the touchscreen and the creation of graphical components. The second one contains the header files corresponding to my specific design. The following step is to add some defines. You can find them in the readme.txt file. There are some differences regarding the type of microcontroller, and some of the functions driving the screen are also different depending on the microcontroller. So, to address these differences, we have to indicate if the STM32 is from the F1 line or the F4 line. Also, for the F1 line, it is necessary to include this define. This is not required for the F4 line. Please read these paragraphs if you are not going to use a Nucleo board F103 or a Blue Pill card. Since we can use different libraries or platforms, we should exclude from compilation some folders. These two are required if we are going to use the standard library, which is not the case. So we exclude from compilation. And this other if we are not going to compile for the STM32F103. And finally, we have to add some lines in the main file. It is assumed that in the main loop.c we have the functions for the setup and also for the periodic task. so we have to add its header file. You will have to modify this last function, and maybe also the setup, to operate with your own design. And it's ready to be compiled. It will take a long, but with a bit of luck, we'll have no errors, and so it will be ready to be transferred to my microcontroller. So you have downloaded an application to set a graphical interface in a touch screen. Although not finished, it's the starting point for a scoreboard. It can be used as a template if you want to create your own designs. However, defining the type of components, the size, the position, color, and also the interaction is a tedious task, mainly if you are going to program against the microcontroller. Instead, in the following minutes, you will see how to do 95% of the tasks in a more comfortable platform, where you can codify and debug most of your design functionalities, or at least those regarding the graphical interface itself. These are the steps that we have to follow. First, we are going to open your IDE. I will use Visual Studio 2010, and I will create a project in Win32. You can type any name, and after creating this project, you will have to include some files. These are in this folder. You can add both source files and header files. There are some things that you have to do. One of them is to modify the type of characters from Unicode to multibyte. And also you have to add some inclusion folders. These folders are most of these folders appearing here. In fact, we have to include the folders with the header files, but also a folder with some sources files. This file corresponds to a previous project, so we should exclude from compilation, but I want to keep it in this project because it has the code that we have to copy in my main file. You can see the fragments that you have to copy in the new main file, but I think that it is better if you copy all of the file and then you just modify one string. This is the screen, and you have to modify the name of your project in uppercase. After doing that, we can compile it, and we will see that we have our graphical interface simulated in my desktop. It is faster and also more comfortable to codify my graphical interface. You can see that all the functionalities appear. However, for example, the timer cannot be simulated, but here I have included this little button to simulate somehow the behavior of the timer.